Hi students. So in some of the universities, Form D first year students are going to face a university examination. Hence, the key topics of the pharmaceutical organic chemistry of Form D first year syllabus we are trying to cover to make them pass in this examination with the introduction and explanation about all these very important aspects. Okay. So as a part of it, we have done 3 videos earlier, and this is one more important reaction, named reaction. As you know, here we are able to get at least one 10 marks question from the named reactions. Hence, we are trying to cover the important named reactions which are present in their syllabus. So today our topic is Perkin's reaction. Perkin's reaction. If you look after the definition of the Perkin's reaction, when an aromatic aldehyde is heated with an anhydride of the aliphatic acid in the presence of sodium salt of the same acid, which acts as a catalyst and produces alpha beta unsaturated acid. Okay, so let us explain one more time about the definition. When aromatic aldehyde is heated with anhydride of aliphatic acid in the presence of sodium salt of the same acid, produces alpha beta unsaturated acid, can also be called as benzoic acid. That is called as succinic acid. Correction, it's not benzoic acid, it is succinic acid. Okay, so here the aromatic aldehyde we are taking is a benzaldehyde, which is treated with the aliphatic anhydride. So this is a anhydride of the acetic acid. So this is called as acetic anhydride. So it is a derivative of the acetic acid. Next, we are taking a catalyst of the same acid salt. So this is as it is a derivative of the acetic acid, salt of the same acid we need to take as a catalyst. So this is called sodium acetate, which is the whole reaction is carried out under a temperature of 180 degrees Celsius to form alpha beta unsaturated acid. Here it is a succinic acid. Alpha beta positions I already explained in the previous videos. Alpha carbon is the carbon which is present next to the carboxylic or functional group. In the case of succinic acid, the COOH is the functional group. So this is the alpha carbon, and the carbon which is attached to the alpha carbon is called as beta carbon. As we have a double bond between alpha beta position, double bond means unsaturated bond. Hence, the name of the succinic acid can also be a general name here. Succinic acid is a specific name. If you look at the general name of it, it comes under alpha beta unsaturated acid. And the mechanism of the Perkin's reaction will take place by 5 steps. Yes, students. So to avoid confusion about all these steps, I have divided these steps, and so that it will be very clear for you for not getting you confusion. Okay. So if you look after the first step here, the first step is the formation of carbanion. How the carbanion is formed? The reaction of an carboxylate with the acetic anhydride. So from where the carboxylate ion has produced, this anion is produced, it has come from the sodium acetate. As you know, sodium acetate will dissociate heterolytically, thereby forming Na plus and CH3COO minus. That CH3COO minus, which we have written in the form of carboxylate ion like this. Okay, so the carboxylate ion reacts with the acetic anhydride. Actually, this carboxylate ion is negatively charged, which always tries to abstract a proton. So the proton will be abstracted from the alpha carbon, which can also be called as active. What it meant says this is also called as acidic carbon. This carbon is acidic carbon because you have a strong electron withdrawing groups on the next to this carbon. Hence, this carbon will become acidic. Acidic carbon is the carbon where the hydrogens present in this acidic carbon will prone to liberate H plus ion. Such carbons are called as acidic carbons. The carbons where the hydrogens are prone to liberate in the form of H plus ions, then those carbons are called as acidic carbon. So here this hydrogen will be abstracted by this carboxylate ion it will be liberated in the form of H plus ion, which will be united with O minus, thereby forming acetic acid. And once it is heterolytically divided, H is liberated in the form of H plus ions, leaving the shared electron pair here. Those two electrons are combinated with the alpha carbon, so thereby forming carbanion 1. Now this, in the second step, this carbanion, this is a anion of the anhydride. Remember, this is anion of the anhydride. This anhydric anion now reacts with the aromatic aldehyde called as benzaldehyde. As we have already discussed in the previous videos, always the negatively charged fragment or any anion will always attack the carbonyl carbon, because the carbonyl carbon is partially positive charge. Hence, this negatively charged nucleophile or anion will always try to attack the positively charged or partially positive charge. Here we don't have a full positive charged carbon, but we have a partially positively charged carbon, that is called as carbonyl carbon. So the anion will attack the carbonyl carbon of the benzaldehyde, thereby forming carbanion 2. Okay. Now this carbanion 2, where the negative charge is present in the oxygen, will abstract a proton. Thereby forming hydroxy acid anhydride. Means this is the intermediate 3. So this is a hydroxy part, and this is anhydride, that is called as acid anhydride. That is the name. That is why we call this as a hydroxy acid anhydride. Okay. In the fourth step, if you see, this hydroxy acid anhydride will undergo internal proton transfer, thereby liberating a molecule of water and forming alpha beta unsaturated mixed anhydride. So here the internal transfer of proton will take place from the alpha carbon. Here this OH will be depleted or removed or broken the bond with the carbonyl or the carbon, so that it will dissociate in the form of OH minus ions. Once it is OH minus ions dissociated, it will abstract hydrogen from the adjacent carbon atom, so that H2 plus water, H2 plus water. Once this proton is liberated, leaving the electron pair there itself, these two electrons will be utilized for forming a double bond. That is how we got as alpha beta unsaturated mixed anhydride, because of anhydride part is also there. That's why we call it as a alpha beta unsaturated mixed anhydride, which is a fourth intermediate in this mechanism. And if you see the last step, that is called the fifth step, where you will get the cinnamic acid or alpha beta unsaturated acid, which on hydrolysis. So fifth step is the hydrolysis. As you know, hydrolysis means hydrolysis, addition of water molecule and breaking down the molecule. So water is a H2O, as you know. This H2O will dissociate or will be broken down heterolytically like this. OH will be the bond formation, and this bond will be broken, so that CH3, CO, OH, acetic acid will be formed, and here C double bond O and hydrogen of the water molecule will be forming a final product, that is called as cinnamic acid. Okay. Thank you, students. We will end up with this reaction today. We will go for next reaction.